It is my great pleasure to welcome John Woodland here this morning. It's lovely to have John back with us again. And today, because he's going to talk about a composer who is also a scientist, I'm going to introduce his scientific qualifications first. John is a chemist with interdisciplinary research experience and a passionate interest in developing molecular strategies to tackle the scourge of infectious disease. He is currently a research fellow at the Drug Discovery and Development Center at UCT, where he conducts research in chemical biology aspects of malaria and tuberculosis drug discovery. He is also passionate about using his skills to promote science and improve scientific literacy in South Africa. And boy, do we need that. But John's other major interest is music. Inspired by the diverse musical traditions of the Cape, his background as an organist led to his interest in choral music. He directs his own choral group, Vox Cape Town, and has volunteered as a broadcaster on Fine Music Radio since 2006. John writes, "As Borodin must have reflected over a century ago, it is a privilege to see the world from both molecular and musical perspectives and to harness their powers to make a tangible, lasting impact." We look forward, John, to how you explore this wonderful sentiment. Welcome and thank you very much.
Thank you so much, Letitia, for that kind introduction, and good morning, everyone. It's very good to be back. I'm so pleased to hear that some of you have gathered together in person and that many of you are also able to join online. It's a great pleasure to be back. But as you heard from Letitia there, what I hope to do this morning is just give you a bit of insight into the life and work of someone to whom I, as a musician scientist, closely relate. That's Alexander Borodin. And I hope to share with you a bit of insight into how he managed, if you like, this tension between the two masters of music on the one hand and science on the other. So I hope you managed to hear a few bars there of that second string quartet by Borodin. I played just the first movement there. He wrote that work very quickly in just a month, in August 1881, when he was 48 years old. And it was intended to evoke memories of him falling in love with his wife, Ekaterina, some 20 years before that in Heidelberg. And it's said, because Borodin was an amateur cellist, that in the cello part, he was sort of depicting himself. He was depicting his wife in the first violin part, and you might have heard a lot of musical dialogue between the two parts. And so the whole work really is just intended to suggest the growing and deepening love between the two. But Ekaterina, Borodin's wife, wasn't his only love. As I mentioned, and as you're probably expecting now, there were these two other competing loves, competing passions. On the one hand, the music, and on the other hand, the molecules. So let's start at the very beginning with Borodin's early life and sort of see how these passions arose. Well, he was born in 1833 in St. Petersburg in Russia and began composing when he was 9 years old. His first work was a polka for the piano for 4 hands, so a piano duet. He was also very interested in painting and would experiment with mixing his own watercolors that he would then paint with. And his mother was alarmed apparently, by these experiments. But of course, they would be quite prophetic, because that's what he would end up pursuing, was chemistry. Although he originally intended to study medicine, in fact, in St. Petersburg at the Medical Surgical Academy, but then he decided basic science, and chemistry in particular, was going to be his vocation, his career, his passion. And fortunately for him, he ended up being supervised by Nikolai Zinin, who was the most famous chemist in Russia at the time. He's referred to as the father of Russian organic chemistry. And just to fast forward a few years, after a postdoctoral stint in Germany, where Borodin interacted with some other very important scientists and chemists of the time, he returned to St. Petersburg and then succeeded his mentor, his supervisor, Zinin, as professor of chemistry at St. Petersburg. But it's worth just taking a slight detour to look a bit more into this character, Nikolai Zinin, who was a very important organic chemist at the time, Borodin's mentor and supervisor, because he himself made a big contribution to chemistry in Russia, and certainly also sort of would have then helped Borodin find his own research interests and research space. Well, there you see a commemorative stamp that's memorializing Zinin. He made some important contributions to organic chemistry in theoretical aspects. Experimentally, he was very interested in organo-zinc reagents. So those are compounds that incorporate the zinc metal ion into some aspects of organic or carbon molecular structure. He was also interested in carbocation chemistry. Carbocations are positively charged carbon atoms. And he was also very interested in the chemistry of functional groups that we call amines, enols, and enolates. And I mention this because it's important, because those are the sorts of functional groups and areas of interest that Borodin would then pursue in his own research. And there was also a pedagogical aspect to Zinin's work. He wrote various chemistry textbooks. And there's a very famous German chemist, August Wilhelm von Hofmann, and most undergraduates will be familiar with the Hofmann elimination or Hofmann rearrangement. It's the same Hofmann, but he wrote, even if Zinin had done nothing besides the conversion of nitrobenzene into aniline, his name would have been inscribed in golden letters into the history of organic chemistry. And I just like to show you, there won't be too many molecular structures in this talk, but here is that reaction that Hofmann is describing, the reduction of nitrobenzene into aniline. It's a very high yielding reaction in the presence there of ammonia and hydrogen sulfide. And aniline is a very important precursor to rubber chemicals, dyes, pesticides, explosives, and pharmaceuticals. So this was a very important reaction that Zinin discovered. So going back to Borodin, then there's some correspondence between Borodin and Zinin, where Borodin writes, "Others have the composition of music as the goal of their lives. For me, it is only rest, fun, which takes time from my serious business as a professor." And Zinin responded, "Mr. Borodin, it would be better if you gave less thought to writing songs. I've placed all my hopes in you and want you to be my successor one day. You waste too much time thinking about music." And then a little quote, which on a personal note is one which enters my subconscious many days of the week. "A man cannot serve two masters." But after he completed his studies with Zinin, as I mentioned a bit earlier, Borodin went to Germany, where he worked with Robert Bunsen in Heidelberg. Bunsen, you'll be familiar with the Bunsen burner that he developed, but he also discovered the elements cesium and rubidium and did some important work in photochemistry. Borodin then moved to Erlenmeyer's lab, where he worked with Dmitry Mendeleev, and you will have heard of Erlenmeyer's name in the context of the Erlenmeyer flask. Mendeleev, of course, famous for developing the periodic table as we know it today. He was one of the first to propose that we should arrange atoms in order of increasing a number of protons. And so he was able to predict the discovery of several elements and their properties just by virtue of the position in the table that they occupied. Borodin also collaborated with an important French chemist called Wurtz and had a bit of a rivalry with Kekulé. So really, the middle of the 19th century in Europe is a very exciting time. Chemistry is really starting to find its own. And these, for a chemist or a scientist at least, are very, very big names. And maybe just before we carry on, a little bit of humor. I mentioned there Kekulé being one of the scientists with whom Borodin worked. Kekulé was very important because he was the first to propose what we call the resonant aromatic structure of benzene, which is an important 6-carbon molecule. And that apparently came to him in a dream. He was drifting off to sleep and thought of or dreamt of the Ouroboros, which is this idea of a snake sort of biting its own tail, forming this sort of infinite loop almost. And that apparently, historically, it's said, it inspired this structure of benzene that he proposed. So there's a little cartoon I came across on the internet a while ago I thought I would share with you. There you can see Kekulé dreaming about this snake biting its tail, which inspired him to think about the structure of benzene. And so he says to his wife or someone, "I've just had a dream about a snake holding its own tail. It's given me a great idea about the structure of the benzene molecule." Then he continues, "Another snake appeared, and the two of them coiled into an interesting double helix." It was all getting a bit Freudian, so I don't think I want to analyze it any further. And of course, you're probably all aware of the double helical structure of DNA. That would be that very important discovery a century later in 1953 by Crick and Watson. So the cartoonist here is a bit naughty. He's mixing up timelines and suggesting that back then Kekulé might already have had a hint into the structure of DNA, but we can be quite sure, chemistry and biology were very basic back then. He probably had never even heard of deoxyribonucleic acid or DNA. So a little bit of a naughty cartoon here. But back to Borodin. Just to talk a little bit more about his chemistry before we go on to the music. He was one of the founders of the Russian Chemical Society in 1868, and there he is in the center, circled. You recognize his mustache, and then this other Rasputin-looking character is Mendeleev himself, the discoverer or the proposer of the periodic table. Borodin he contributed a lot to organic chemistry, notably the synthesis of benzoyl fluoride, which is the first aromatic fluorine compound to be described. And here he reacted benzoyl chloride and potassium hydrogen fluoride, and they together give this compound. He also developed a technique for quantifying the amount of urea in urine, which was quite an important quantitative experiment at that time. And it's said that this clearly tricky apparatus was designed by Borodin, and you can see there the reaction of urea with sodium hyperbromide giving these products at the end. He made important contributions to discovering the structure of compounds amyrine and benzidine, and also describing the Hunstdicker reaction, which is a reaction between silver salts of carboxylic acids and halogens leading to organic halides, which are also very important molecules in organic chemistry studies. You can see in this example here, bromine is reacted with the silver salt in tetrachloromethane to give this organic halide. It follows quite a complex reaction mechanism involving radicals, which weren't fully understood until much later. But sadly, although Borodin published that in 1861, it was patented by the Hunstdickers in 1939. And at that time, it was fashionable to name reactions after their discoverers. And so sadly, we know this reaction now as the Hunstdicker reaction and not the Borodin reaction. But perhaps a sort of further injustice, historically almost, is when it comes to the aldol reaction, which is a reaction all undergraduate chemists will be familiar with. It's a very important tool in the chemist's arsenal for forming carbon-carbon bonds. So this particular reaction is used daily in chemistry research labs in the production of very important pharmaceutical and other compounds. And essentially, it involves the reaction of a ketone enolate with an aldehyde to give a so-called aldol product. And you will notice that line in red that indicates the new carbon bond that has been formed. Aldol being a portmanteau of aldehyde and alcohol, which is a motif of many of these structures. Now, the thing is, it was discovered independently by both Borodin in 1869 and this French chemist Wurtz in 1872. And you can see there an extract from Wurtz's paper. But because in the late 19th century, naming reactions after their discoverers was very unfashionable. It just was given the generic name of the aldol reaction, which perhaps makes sense because it's quite nice to have a reaction named in a way that tells you what the reaction does rather than just after a person. But it's interesting to reflect that in another era, perhaps, this reaction would have been called the Borodin-Wurtz or the Wurtz-Borodin reaction. And, you know, chemistry students all over the world would be familiar with Borodin's name, whereas these days, Borodin is really better remembered as a composer rather than a chemist. And so if I were to mention Borodin to many of my colleagues, chemistry colleagues, they wouldn't know who he was, but mention Borodin to almost any musician, and his name will be familiar to them. So perhaps then let's talk a bit about Borodin's music. He played the piano, flute, and cello. He regarded himself as a Sunday composer. So as in the correspondence with Zenin earlier, composing was just something he did for fun on Sundays when he had time on his hands. And in fact, there's a story that many of his musical colleagues wouldn't wish him well. They would wish him ill, because when he was ill, he would write his music because he was stuck at home. So obviously his musician colleagues wanted him to compose and write music. So instead of saying, Mr. Borodin, we hope you're well, they would say, we hope you're ill, because that would mean he'd devote time to writing music. But Liszt, Franz Liszt, realized what an important composer Borodin was and would become. And so Borodin and his music were promoted outside of Russia by Liszt. Within Russia, Borodin formed a group called the Five, or the Mighty Five, or the Mighty Handful, to develop a Russian nationalist style of music. And you've probably heard of some of the other people in this group, Mussorgsky, Rimsky-Korsakov. In this particular picture, Stasov is a music critic. Balakirev was very important, Cesar Cui as well, and then Borodin on the right-hand side there, circled again with his moustache, being the fifth constituent of this mighty handful. He wrote not very much music, but what he did write was very potent and very memorable. He wrote 3 operas, of which Prince Igor is the most famous. He wrote 3 symphonies. He wrote a beautiful symphonic poem in the steppes of Central Asia, very atmospheric. A lot of his music is programmatic, which means that it has an extra musical stimulus or a story or a narrative behind it. He wrote 2 beautiful string quartets and other chamber music. We heard part of the 2nd string quartet at the start of this talk, and then some solo piano music and several songs. And in fact, it's been written by a contemporary music critic, but no musician has ever claimed immortality with so slender an offering. So it's really quite remarkable, once again, that Borodin could balance these 2 masters, these 2 passions, the molecules and the music. But what music he wrote was so potent and powerful and memorable that he could establish his reputation as a first-rate composer with so little. So I thought we'd take a little bit of a music break quickly, and I'd just like to play for you the first movement of the Symphony No. 2 by Borodin. It's a recording by the Concertgebouw Orchestra in Amsterdam, and you might recognize this first movement of the 2nd Symphony. It's very powerful. It's meant to depict a gathering of Russian warriors, and Borodin has used Russian folk music as an inspiration for some of the melodic material. And in fact, the symphony used to be known as the Heroic Symphony No. 2, but that's a name that has fallen away in more recent times. So here is the first movement of the 2nd Symphony by Borodin, played by the Royal Concertgebouw Orchestra. First movement there of Borodin's Symphony Number 2 with that very imposing grand theme. I love it, but I remember having a conversation with Rodney Trudgeon where he was saying it's too aggressive and bellicose for him, that first theme. And I would encourage you to listen to the rest of the work if you don't know it. There are wonderful contrasts in the subsequent three movements. And in that recording, we heard there, perhaps you recognize the performance space. It's the Concertgebouw in Amsterdam with the Royal Concertgebouw Orchestra. So Borodin died at the age of only 53 in 1887. He had a heart attack at a fancy dress party for his colleagues. I suppose that's not the worst way to go, but you can see there his tombstone in St. Petersburg with some of the most memorable musical themes that he wrote inscribed behind that bust. And as I mentioned earlier, it's sort of ironic that for him, chemistry was his primary passion, composing was secondary, and yet today he's better remembered as a composer than a chemist. But sometimes the balance is right, and here's a lovely Google Doodle that was published a few years ago, in which they were celebrating an anniversary of Borodin's, and really highlighting here both his molecular and musical contributions. So I'd just like to change tack just for a few more slides. And I did mention in the background to this talk that we might think of Borodin as the only composer-chemist the world has yet seen. But if there were to be a runner-up for this title, I wonder if you could guess who that might be. In fact, it's Edward Elgar. He's the only other well-known composer we know today who is also an amateur chemist and made some important contributions in the field of chemistry. Who knew? But here's a picture of him relaxing in the laboratory, the shed at the bottom of his garden that he nicknamed the Ark. It's very odd to see this familiar image of Elgar in a laboratory context. You're probably familiar with much of his music, works like the orchestral suite, The Enigma Variations, his 5 Pomp and Circumstance marches, one of which is that famous Land of Hope and Glory song one associates with the BBC Proms, a haunting cello concerto, 2 large symphonies, many oratorios such as The Dream of Gerontius, several beautiful choral motets, and also some organ music, of which I can highly recommend his organ sonata in G, one of the few 20th century sonatas that was written for the organ. But he also made time for chemistry, and in one of his letters to his publisher, Jaeger, whom you probably know, that important Nimrod movement in the Enigma Variations is dedicated to Elgar's publisher, Jaeger, with whom he had a very close friendship. He writes, "I'm resuming chemistry and made soap yesterday, saponification reaction, between scoring, not scouring, the symphony." And in fact, Elgar developed a very important apparatus for delivering quantities of hydrogen sulfide, which was an important reagent used for the qualitative analysis of inorganic group 2 metals. So there's some literature around this as well. So once again, gosh, what a polymath someone like Elgar was. And maybe just looking to chemists in other fields, because there isn't just an overlap between chemistry and music. But do you recognize this face? Are you able to put that to anyone or some more contemporary personality? These are in fact some very early photographs of Margaret Thatcher, who trained as a chemist before she entered politics. And she was actually responsible for being part of a team that developed the formulation for what we now know as soft serve ice cream. So once again, perhaps those analytical and problem-solving skills she developed as a scientist may be transferred over into a political sphere. And in fact, when I discovered this back in 2010, when she was still alive, she was still regarded as the world's most influential woman. There's another very famous chemist who's a politician today, Angela Merkel, although we might prefer to call her a physicist, but actually her PhD thesis was in quantum chemistry. So really understanding very simple molecules and electronic interactions and those kinds of things. And there she is speaking at the International Year of Chemistry, which was back in 2011. And in fact, there's another European leader who also has trained as a chemist, the Prime Minister of Belgium, and there's a little cartoon that says something like, you know, the table of Mendeleev here becomes the budget table of Elio Di Rupo. So an overlap between politics and chemistry as well. And in fact, in the arts, there's one other famous chemist who comes to mind, and that's Natalie Portman, the actress. And in fact, she published a paper when she left high school for a method to demonstrate the enzymatic production of hydrogen from sugar. So maybe some overlap then between chemistry and the arts in a general sense. But maybe just to return to Borodin, I'd like to share one more short extract of his music. You'll no doubt recognize part of this. It's the Dance of the Maidens from his opera Prince Igor, in this beautiful piano transcription, which I think is wonderfully executed. But I'd encourage you just over the next 2 or 3 minutes to reflect over the mind of someone like Borodin, who could succeed, excel, contribute, leave a legacy in both chemistry, in molecules, but also in musical terms as well. Thank you very much. Thank you for your kind attention. I'd be very happy to take any questions or perhaps any comments or observations you might have.
There we are, some warm applause from here in the hall. Thank you very much, John. That was delightful, very, very interesting. I'm sure there'll be some questions or comments.
Thank you, Letitia. Thank you, everyone.
There's a question here. Did they use some of his music in the film Battleship Potemkin? Did you get that question?
Yes. Was some of Borodin's music used in that film? I'm not quite sure. It's quite possible. Regret I'm not familiar with that film, but indeed, Borodin's music's been used in many, many films and all sorts of other productions. And I think even a musical was constructed of some of his, is that Kismet, I think. It's great that his music has found even wider audiences beyond sort of the traditional concert hall.
Hello, John. I'm Robin Lee. I wondered if you could give us a bit more about his personal life. You didn't mention whether he was married or not, whether he had any children, and why he went to fancy dress parties.
Thanks, Robin.
Deadly ones.
So the fancy dress party, I think, was his own mistake, because from what I'd read, that was a party he threw for his colleagues, which maybe gives us some insight into Borodin. In that sense, not a stereotypical scientist, perhaps. He seems to have had a very fulfilling personal life. I did mention at the beginning, because I played that short extract of the second string quartet, he wrote that for his wife, Ekaterina. They met when he was about 28, and they had a very fulfilling and devoted relationship, which is also quite refreshing, I suppose, from not only a science point of view, but a musical point of view, because one's always hearing about these composers, on the one hand, being very sort of isolated and doing their thing and no time for those things, or the other extreme where they're perhaps these womanizing people of sort of ill repute. So Borodin was, in that sense, seems to have had a very balanced, fulfilling, principled life. I'm afraid I can't answer the question about his children, but I wouldn't be surprised if he did have children. Perhaps Borodin's descendants walk amongst us and have subsequently made contributions in chemistry and music.
John, Gert, yeah. Was he well accepted as a musician during his lifetime? And what made him famous as a musician eventually?
Yes, that's a great question, Gert. I must admit, not like too sort of clued up in that whole mid-19th century Russian sort of musical milieu. But my understanding is that, yes, he was very well accepted and received amongst his colleagues. As I mentioned, he was part of that famous group we call the Five, or the Mighty Handful, really sharing his music and advising and composing with other great musicians like Rimsky-Korsakov and Mussorgsky. And I'm quite sure they wouldn't have cooperated and worked together if they didn't all feel, one another, they were sort of on an equal footing and had something to give. I forget the exact details, but for example, Borodin left a lot of his work unfinished when he died. Things like his opera Prince Igor. And for example, Rimsky-Korsakov, we also know he wrote Scheherazade, some wonderful music. He spent a lot of time making sure that Borodin's music was completed. He orchestrated a lot of those last bits of Prince Igor, and I think also did a lot to promote Borodin's music. And as I also mentioned, I'm not quite sure how they came into contact, but Franz Liszt, who is really the great performer of that time, and doing things on the piano that people had not dreamt was possible. He championed Borodin's music, particularly in Belgium, France, and Germany. And so that must have gone some way to sort of laying down Borodin's sort of reputation and sort of kickstarting his musical legacy. So I think he was very well respected. And as I also mentioned, in fact, so much so that his colleagues would almost sort of wish him ill so that he could compose. So strongly they felt was his compositional talent and force. But remarkable how history does play out, that sort of ironically he's remembered better today as a composer rather than a chemist, even though he made important contributions to both. And one might even say, who knows, objectively, you could argue that he made bigger contributions to chemistry than to music. But I guess that's also the nature of the arts versus the sciences. Composition is such a personal kind of thing. Only Borodin could have written Prince Igor. No one else could have written what we know today, that beautiful melody we just heard. No one else could have written that but Borodin. But Borodin discovered the aldol reaction. As we saw, he wasn't the only discoverer of that reaction. Wurtz discovered it too. So even had Borodin not done the chemistry, somebody else would have discovered those things at a later stage. Yeah, very interesting sort of tension between these infinitesimal, almost objective contributions to science, but these very personal contributions to music on the other hand.
Oh, could I just deal with what's come up on the chat box? This question from David Pike. Didn't he leave his third symphony unfinished? What there is of it is very beautiful.
Sorry, not the Borodin expert or authority here, and I'm still properly exploring symphonic music. So certainly his first two symphonies I'm fairly familiar with, but must admit, can't offhand think of his third symphony. It's very likely that he did indeed leave it unfinished, what with him dying very unexpectedly at a young age. And it was probably someone who perhaps did finish the work. Just learn a little bit more about that third symphony and listen to it again. You mentioned what there is of it is very beautiful. So thank you for that.
We've got something in the chat box which I could read to you. In 1954, he was awarded posthumously a Tony for adaptation of his music scores for movies.
Amazing. It's interesting because a lot of his music was, as I mentioned, programmatic, in the sense that it wasn't just sort of abstract, beautiful music, although it is beautiful, but it was often inspired by a very specific narrative or program or theme or stimulus. And I guess that music tends to lend itself well to adaptation, to films and musicals and all sorts of other things. So great. I'm glad there's been some contemporary recognition as well.
John, this has been fascinating, a lovely way to start the week. Thank you for sharing your own interests and enthusiasms with us. We look forward to having you join us again in the near future. Thank you very much.